Everybody talks about AI models, ChatGPT, Claude, Gemini, but almost nobody is really talking about infrastructure, what powers them, what makes those breakthroughs actually possible. The answer isn't just algorithms, it's infrastructure, it's data centers. But we're about to spend over 800 billion on them. Yet the AI that this 800 billion will generate is only being very optimistically 200 billion. So the real question is, will these huge investments one day actually pay off? Is this CAPEX justified? Or are we in a big bubble that is just about to burst? So is this CAPEX actually justified? We are really experiencing the biggest capital wave in the entire tech history. Meta is investing 65 billion in data centers, Google 75 billion, Microsoft 80 billion, and Amazon just announced over 100 billion. And all of these are annual numbers, so these are money that they will invest every single year, and actually most likely they will also increase over the years. And actually, if we want to get an aggregate number of the total capital spending, well, we can do it thanks to this article you will find in the description of Sequoia Capital. Well, we can use the following formula. We take Nvidia's revenue run rate that is forecasted for 2025, meaning the end of 2025. We multiply by 2 to reflect the cost of data centers, because about 50% of the total cost of ownership are GPUs, and the other halves include energy, buildings, backups, generators, etc. And then we multiply by 2 again to reflect the 50% margin that the end user actually pays, like startups and businesses buying compute from AWS, Azure, and Google Cloud, and all the cloud providers. Well, as you can see from this table, the projected $200 billion in revenues from Nvidia in 2025, we then apply these two very back-of-the-envelope formulas, and we get to a staggering 800 billion cost of the total AI infrastructure spend for only 2025. Then if we compare this 800 billion with the actual AI-generated revenues, well, the image gets even crazier. We can be very generous in this forecast and give 15 billion of revenues to all the big companies like Google, Microsoft, Apple, Amazon, and Meta. We can also add to the picture also 5 billion for all the smaller players like Oracle, Binance, Alibaba, Tencent, X, and even Tesla. We can add to the picture even a lot of other players, and by being very generous, we can maybe get to a 200 billion figure for 2025 forecasted. And again, this is a very optimistic number. And if we compare this to the 800 billion in spending, which also is very conservative by the way, because the margin for Nvidia is much more than 50%. But again, we want to make this back-of-the-envelope math kind of conservative, and still we end up with the huge $600 billion gap between the spending and the actual revenue. So the real question we're trying to answer is if this number is actually justified. It seems like it kind of is, and even if it's not, the big companies don't really have a choice. It's a high-risk investment, but necessary investment. The ROI, yes, the ROI is absolutely uncertain, and the big companies don't know when or even if the money will be paid off. But the game theory says that you really do have to invest if you are one of these huge companies. And that is because you really cannot afford your competitors to take the lead in AI. This is what's called the prisoner's dilemma. Meta, Google, Microsoft, Amazon, they are all stuck in this dilemma. Zach himself said that if AGI comes, well, I guess good. And if it doesn't come, it's a bad investment. But still, we are forced to do it because we cannot afford the competitor to take AI before us. So we are here watching the biggest player, the biggest company in the world, burning hundreds of billions in AI infrastructure without even knowing if the investment is worth it. But the real question is also, what are they really spending this money on? And that is the $800 billion question, because the vast majority of this money are actually flowing into data centers. And that is why data centers can actually become the most important asset to own in AI. But the thing about data centers is that they are not just warehouses with servers. They really are the industrial bottleneck of the AI revolution. And mastering them may be the most important competitive edge in the whole AI picture. But data centers are very complex to build. Why is that? Well, there is this fundamental misconception that a lot of investors have that data centers are really just real estate. And many investors and builders are getting into the space as tourists. But data centers are really complex technical infrastructures, not just building with the powers and networking. They require careful planning around uptime, generators, cooling and water, not just square footage and power supply. A lot of these new investors and tourists do not know what are the real implications of, for example, generator lead times, which to these days can take more than 90 months to get, like 90 months. That's a lot. And they are really clueless about it. So many argue that a new wave of fake data center is coming. Fake data centers because they don't have a real plan for water, cooling, or power. They exist on paper, but they will likely never be built to the end, or if built to the end, not actually used. And because of this oversupply of a fake data center, there is the risk that there will be an illusion of oversupply, with then a sudden realization that most of this capacity is actually useless. But it gets even crazier, because even if you build the real data centers, there is a high chance that the real data center will get obsolete by the time you have finished training your model on that data centers. In fact, it is very likely that nobody is ever going to train the same model on the same data center twice. And that is because the obsolescence of the actual data center. Think about it, data centers are built out of GPUs. And if you think about the H100s, the state of the art for a lot of time, well, that is just past already. Think about the B100s, the new cheap state-of-the-art GPUs announced by NVIDIA. They are super good on a price-to-performance basis, and they are already completely sold out for the whole 2025 because of AWS, Azure, and Meta already pre-ordering huge amounts of these B100s. But then again, what about after the B100s? Even if you build a real one, they are going to get outdated likely very fast. And that is because each new generation of models outgrows the previous infrastructure, and that is why you actually never train the same model on the same infrastructure twice. So the question here is, why do we have to make bigger and bigger models? Why don't we just make smarter models? Well, this is an open debate, and the core question here is, can model efficiencies improvements like reasoning, retrievals, or compressions actually outpace the physical infrastructure build-out, which translated is essentially the scaling law question. A lot of people argue that models are getting increasingly similar across different labs. There is no real competitive edge there because AI researchers can just jump from one lab to another. And therefore, models are really just becoming a function of the data center. The bigger the model gets, and the more important the scaling laws become. So are actually AI researchers going to come out with the breakthroughs faster than we can build the new data centers? Well, if yes, maybe we don't need as many new data centers. And one example that we can see here is DeepSeek. There's a huge breakthrough in the algorithm, in the actual model. But if no, then the scaling laws really dominate and the physical infrastructure become king. In both cases, there seems to be a lot of consensus around the fact that scaling laws still dominate to this day. But the point is that we don't really know yet. But do we actually care? Well, what's for sure is that the big players are not waiting around and see. Instead, they are picking side, and they are doing that by owning the game, from silicon to software. They are vertically integrating. In fact, vertical integration is becoming not only smart, but necessary. It's becoming more and more clear that you cannot separate the model from the infrastructure. The team has to work on both. You can't have different teams for a model and infrastructure because it's so complex to work on the infrastructure. That is why the team has to be a unified team that works on both model and data centers. To do that, you have to verticalize, and hyperscalers are actually doing that. And yes, they are doing that to control the performance, but also to internalize the margins. If you want to know more about this, click on this video, but the important, but it's getting again more and more clear that if you want to own your margins, you really have to own your infrastructure. You have to own your compute. And we have seen this $800 billion question, the biggest capital wave in the history of tech. Again, this number is nuts. Zuck with Meta fully owns his data centers. Google as well, and they also have probably the best distribution channel. The partnership AWS and Anthropic is already changing, with the AWS moving vertically with the Trainium, its own chip, and Nova, its own foundational model, and over 100 billion to back up this bet. The only one that is not doing that is actually OpenAI. In fact, OpenAI is still relying on Microsoft, but this pairing will eventually face structural limitation unless they unify data center and model development. And again, because we've seen that running the model and building the infrastructure now must be deeply coupled. So we're seeing this big tech race to control the full AI stack, model and infrastructure, because that is how you internalize margin and unlock extra performance. And while OpenAI is focusing on model only, Elon Musk with xAI is building an entire vertical stack from scratch. And at the center of all of this, there is Colossus, a massive supercluster of GPUs, and that is already powering Grok. And if you want to see the proof that owning your infrastructure actually matters, just look at Grok and the crazy rapid improvement that it had. In fact, in just a few months, Grok started from 1 to 2 to now Grok 3, with really dramatic improvements at each step. Like seriously, look at this graph and how much time it took Grok 3 to become as good as OpenAI's latest model. So what has changed really? Not some magic algorithmic improvement. What has changed was Colossus, the supercluster of xAI and its vertical integration. Colossus is possibly the largest GPU cluster in the world, with 200,000 H100s, and reportedly is going to expand into 300,000. Scale still works. At least for the moment, bigger clusters literally equal better models. And when you control both the model and the data center, you really can squeeze that extra performance that the others really can't. So yes, Elon is not just building a Grok, he's assembling a full vertical AI stack, exactly as he did with Tesla for electric vehicles. Colossus is the industrial manifestation of this AI bet, and the Grok progress is the proof that it works. But building your own vertical AI stack is not that easy. It's actually an engineering nightmare, and the real bottlenecks are not what you think. To understand how AI is not just digital, but is actually physical, we're gonna use a partner of Sequoia's Capital new framework, different framework from the classical triangle compute, data, and algorithm, from a new industrial framework that represent the real 3 bottlenecks to expand AI's capabilities. These new 3 strategic pillars are servers, steels, and power. First, let's start with servers. This is the silicon layer of the stack. It is clear that this layer is still governed by Moore's law. Again, look at the improvement of the B100 versus the H100s, and the chip war is just beginning. Nvidia has huge margins, and that creates a lot of hunger among competitors to join this layer. In another video, we talked about Grok's LPUs that use only 1/3 of the energy per token, and the overall CAPEX plus OPEX is smaller than just the OPEX of traditional GPUs. Now, I would never bet against Jensen, which is Nvidia's CEO, but still, it seems like a lot of new players are coming into this war. But let's move to the second pillar, which is steel. Steel is really a shorthand of all the industrial infrastructure: diesel generator, battery systems, racks, liquid cooling, HVAC and backup systems. And the third and last pillar is power. purely energy generation and grid limitations. In fact, I would argue that power is becoming the ultimate constraint and bottleneck for scaling AI. We just do not have enough generator capacity to power all the global GPUs. There is a growing mismatch between the people that have the power and the people that have the GPUs. Data centers is that golden spot in the middle. But let's go back to Elon. Where does Elon fit in all of this? Well, Colossus doesn't just align with the sum of these three. It actually checks perfectly all of the three pillars. Servers? Well, we've seen how Elon already locked 200,000 GPUs and soon 300,000. Steel? Well, from Tesla Gigafactories and SpaceX Starbase, Elon has a proven track record of industrial perfect execution. And in fact, the Colossus supercomputer was built in just 122 days. This is impressive, especially considering that a data center like that would typically take multiple years to build. And then finally, power. Reports say that xAI has already secured 150 megawatts of power from Tennessee. And remember that Tesla is literally building energy products, from solar to grid to storage. Elon Musk is really vertically integrated. So what does all of this mean? AI isn't just software anymore. It's infrastructure, it's construction, it's power grids, it's steel, it's a server racks. It's really a run race in atoms, not just bits anymore. And Elon Musk is one of the few people that really understand this. Colossus is exactly the proof of that. Elon is not just building models, he's owning the stack from top to bottom. And while other players are focusing on models and clouds, Elon Musk is laying cables and firing up turbines. This is the new game. Whoever controls the chips, builds the steels, and powers the grid wins. Not just AI performance, but margins as well, speed of deployment and independence. There is a very high likelihood that the next chapter of AI won't be written in code, but it will be poured in concrete. So welcome to the new industrial age of AI. Click here before the end of the video if you want to know about some more players that may win the infrastructure war. Thank you for listening, see you the next time.